Hello to everybody. I hope you will find this tutorial interesting. So basically, I made a webinar about like using ChatGPT, like to make super attractors, and like that webinar like was just let's say for the people who subscribe to it. But I wanted also to do something for the YouTube since it was also requested. And I wanted to do something like with ChatGPT in Python, again in Grasshopper. But let's say something of like an easier nature to follow, let's say. So today we will be speaking about Lissajous curve, Lissajous. Who knows how? I'm not really good in saying words, in pronouncing them. So basically, this is a curve where the point, so it has its parametrical equations that has parameters. And parameters, when they change, it creates this kind of curve that repeats itself. And here it's really based on the sinus and cosinus, and it's, let's say, and like their relationship between each other. So these curves usually so basically it's like it represents the relationship between cosinus and sinus, and when not the same, like there's certain discrepancy, it creates this kind of really interesting kind of geometry. So today we will be speaking about how to make this baby in ChatGPT. But first of all, I would like to speak about what is sinus and cosinus, because actually a circle can be also described as this type of the curve. So we will be speaking about that. So let me go for a moment to Rhino. Let me close this. So what is sinus and cosinus? Sinus and cosinus is mathematical functions that we use usually to make the shapes that repeat itself. But like, why is that? How is that? Like, you know. So let's start for the moment. Just to make a simple example. So basically, sinus and cosinus, they represent the movement of the point around the circle. So let's make a circle. So I will make circle 1 to 1. I don't want this grid here. So here, I mean, it's not, let's say it's not a basic tutorial, like it's not like a hard one, but I accept that you know what is Grasshopper and how to open components. So I will just preview off and then connect it to the curve. Okay, here we are. So let me make a cute color. Think. Okay, and let's construct point. And we're gonna use sinus and cosinus. Ecco. So this one we connect here, this one we connect here. And we will make P slider, let's say. So, and the factor will be from 0 to 2, because it's a circle. So, from 0 to 2p. And in the middle, it should be, so let's say 0, 0, 0, so that it moves smoothly. So when I move this, so this is like an angle, let's say. So basically in this case, this is like radians. So this is an angle. It represents, or you can also think of it as a time. Yeah, you know, so like with the time, the point moves, and this is like represents the time. And then it passes through sinus and cosinus here. And we are creating a point, and I'm using this as my x and this as my y. So if I start to move it, you will see that it goes like this. So it makes, but let's say, for example, like 2p is the length of the circle. Let's say we will make it 10, whatever. And as you can see, so we move on, move on, move on. So sinus and cosinus, it describes the movement around this circle here. Thing. And what if we use, let's say, different sinus and cosinus? So this is what happens. This describes my movement in x direction, and this describes my movement in y direction. When they're the same, they're on the perfect circle. So when we do like this, think. And so the point just goes around the circle, and because the circle is infinite, so the shape repeats itself. Yeah. But if we move only one p factor, it moves on the axis repeating itself again. So because it likes it goes in circle, but only on one axis, let's say. And when you move these and these, yeah, you create points, and this discrepancy between two factors, like their relationship, can create really interesting geometries. So like if, for example, so for example, I put now cosinus 2x. So yeah, it's just different coordinates of the points that passing through this function, they go around. So let's go. So we are making this thing here. And how do we do that? So we will use Python for this to describe this curve. But before that, let's start to put on parameters. So first of all, we will need Python, which you can find under the panel, under subpanel Python, under the script subpanel. And we put this one, gh Python script. When you double click on it, you get the editor. Here you get like the imported library. And here you have some basic information about who is this. Here, as just like with any other components, we have inputs. So this can be the parameters that can change, for example. And this is the output, which we can reuse then later in the code. As you can see here, when I double click on it, it's imports. So first part when you write your Python code is the first line where you import stuff. So this can be, for example, here, the imported Rhino's script syntax. so that you can create Rhino geometry inside Python. So basically, it's different libraries, different things that you can put as a resource to your code. So first, you have the import stuff. Here, for example, they have Rhino script syntax. Yes. It is a language that you can use in order to program the things also in Rhino without Grasshopper, etc. But I don't suggest to use this one. I usually prefer. So when we start to write, you see that the words, they change the color depending. So it means that there is this function there. I prefer to use Rhino geometry, which is more basic name is Rhino common. When you put a point here, so I put a point and here we have stuff, okay. And like when I click G, he will already show me geometry. And then I say srg. So I prefer to use Rhino geometry. Why? Because Rhino geometry is basically the language on which is written Rhino. It is the language, it's the full language of Rhino, let's say. So it has all of the functions, everything, because Rhino script syntax, let's say it's like a shorter version of this, and it's slightly different, and some things like they're not there in Rhino script syntax, and the more common thing to use is Rhino geometry, so that you have all the tools that you need. So we imported this here, Rhino geometry as RG. Here you could have write anything, like it could be, I don't know, HG. And like when you write in future, he understands that you mean Rhino geometry, because if I would be writing all the time Rhino thing, geometry thing, it would be a little bit too much. And so here you have all of the functions. And here we have also the help that usually has some, like it says what the code wants to hear from these functions. So like circle, radian, like, so how do you want to make your arc? So here it is. So I will import it as RG usually. And then here, you have the back button. So if your code is fine, it works. So let's say, do you want to apply? Yes. Let's say I want to make a code that like will be my small calculator. So one. So I connect one here. That basically is like calculator. So we have x and y, and let's say a will be, I have problems with my keyboard always. X plus x, x plus y. Here's the result, 3. So let me connect panel. So okay, we used Python as a calculator. Yay to us. So I'm so sorry. I always say so much so in all of my tutorials, webinars. I'm trying to get rid of it, but it's hard. But okay. So okay, now he shows me red. Red means that there is an arrow of some kind. And here it says unsupported operand type. So he's like, where's your x and y, basically. So if I delete this and run the debug, you will see that now it's green. Okay, so let's try to code this with ChatGPT. So first of all, I will copy the name because I'm not good with writing all of these letters. So let's ask ChatGPT to make a code for us for this. So, hi there. Make me a code snippet for Lissajous. I'm so sorry. I should find how to pronounce it. But okay, I hope you forgive me. So, make me a code snippet for this curve to use in Python Grasshopper. So here it is. So one thing, he might here make your code with Rhino syntaxes. If he does Rhino syntax, you just tell him like redo this with Rhino geometry. It's just that my ChatGPT already learned that I use Rhino geometry. Okay. So let's start. So we just copied and put it here. So and he made something, I think. So he made something, but I don't know what. I think it looks like a points. Let's see. Okay. Okay, so what's the problem here? First of all, I don't like that the output has the same name as the frequency, to be honest. So I will put it, I will put this as a curve. So yeah. So here, when you have the output, yes. So basically you need to have the same name here. So we have here an A, here we should have a name. But here we have this problem that there is a variable A, then it becomes a curve. Like you can do it, of course, like you can use one name parameter and then use it as an output, like you can. But I suggest you not to. So I will rename this as a curve. And I will need to put it also here, like this, so that they're the same. But he didn't do it. And to be honest, I usually don't like to create the polyline here. Like, let's make it simpler. Let's make it just points that we will be connecting later. So let's go back to ChatGPT and tell him I want only points as my output. And please don't use the same variable for output and input of frequency. Okay. Okay, let's Control C, Control V, and we put it here. And of course he named it now like as an A, so let me also name it as a A. He made like 200 points. To be honest, let's start with 10. Okay, here we are. We have something. Okay, then let's connect here. So we want to have the curve. So now let's make NURBS curve. NURBS, okay, vertices. That looks strange, no? But because he is trying... Okay, let's make polyline. Let's see polyline. Ecco. Ah, okay, so he's just creating like... Yeah, okay. So basically he used it as a, like the control points. So, but it's interesting. Or like kind of interesting geometry here. We will see what we will use at the end. So we have something. It definitely looks like something. Let's create a curve with another way. Let me go to the panel curve. Spline. Let's say interpolate. Ecco. So think. So here I make just an easy interpolated curve between the points. And now let's say, so we have here frequency. So let's say we use 3. And we get a different curve because the frequency changed. So yeah. So now we have here all of these parameters that are basically like already written here. So like I can change my parameters like amplitude 20, so it becomes bigger. Then number of points, let's see, I will use 30. Then the frequency here we can change. So the frequency is basically how much the waves we're gonna get. So like, for example, if I put here 1, it makes something super simple. If I put 5, it will start to have more motion, let's say in this direction here. If we change frequency x, so we're gonna get a different number of the waves in another direction. So like, for example, here he cannot do it. Let's say 6. Let's say 10 points. Let's see. So we change the parameters to get okay, something went wrong. Let's say 5, 3, 3. Okay, here. So depending on how you change it, you get different things, and you can try different numbers. So for example, here it's not changing, here it does. We can do, if we do like just 1p, it's just a line. If we do 3, it should get more repeated. Okay. Okay, this is something else. So of course 0 will give us 0. So let's say we do more points, and it starts to look like a circle. So when as you have seen, like we spoke about with your cosinus and sinus at the start, it's because this curve actually can represent a circle if their frequencies are the same and if sinuses and cosinus are the same. So this is exactly what happens here. So here we go here, and basically that's the mathematical formula that is used to calculate the points, and that is how it starts to calculate the next point. So we create so basically how this works. So we have these inputs here. Then we have made an empty list to store the points. Then we need to create a number of parameters. Yes. So we make list of numbers. Yeah. And then each number in this list here gets applied these, let's say, mathematical formulas, which get us x and y of each point. So if I put here even more numbers, he will make me almost like a perfect circle, probably. So let's see. And yeah, here we are. But as long as the frequency x and frequency y are different, we are starting to get the fun thing coming. So this is, for example, our classical curve that, how to say it, like the classical curve of the infinite. But if, for example, I will divide it not by 2 but 1.5, it's already changes the shift between x and y. So it starts not to be in the middle. So first, when we do it by 2, the intersection was here. But now it's here. So let's change it. So like, let's say 0.5. Okay, it's really close to the start. Let's say 0.8. So we get the parabola. Okay. 11. Okay. Super interesting. Okay. What else could we do? We could put these para inputs here so that we can control them here. So let's do it. You need to use the same names. So I think I cannot rename it when it's opened. Okay, so So you just click on the right button and you rename it. Quite simple. I need to write it. Okay. I don't know why, but I have sometimes problems with my Rhino. So okay. Phase shift. We can copy it actually from the ChatGPT. Like I will put it on another screen of mine. So okay, just to make it. Phase shift. Number of points. Amplitude. So phase shift, it will be P. Okay, let's just delete it. He will be showing red, but it's okay. Let's put 0 to 10. Okay, here he's showing us red. Let's see why. Okay, so what is happening here? Let's see. So he cannot get a number of some kind. So it could be because we need integers here. So this is what he says, range integer. It's because all of these numbers have to pass here as the whole number. So in order to do it, I will click here, type hint, and choose integer. I'm not gonna stop on this too much. Oh yeah. And now we have a complete control. And you can change it in any way you want to right now without making it, let's say, without changing the code there. So maybe I could use less points. Let's see. So it almost looks like it rotates, like it is a geometry that is rotating. So add to P, it makes, and more points you have, better geometry you're gonna get, of course. So for today, that's it. I think it was a nice way to pass this hour. So, so that's all. Thank you so much and have a great day. Have fun with this.